Hello, and welcome to this C++ Builder developer skill sprint on encrypting AppTethering send-receive data. My name is Al Manarino, and I'm one of the Embarcadero software consultants. This skill sprint will cover how to use the new AppTethering encryption hooks in C++ Builder to encrypt the data or stream before sending the data or stream to other AppTethered connected devices, and how to use the encryption hooks to decrypt the data or stream after receiving the data. The purpose of these developer skill sprints are to give you about a 20-minute session that focuses on a new skill that you can use immediately, and to get answers to your questions in a live questions and answers session at the end of the skill sprint. The blog notes link you see at the bottom of the slide gives you the replay of the session, including links for sample projects used in this skill sprint. This skill sprint on encrypting AppTethering send-receive data and streams works with Rad Studio 10 Seattle, both with Object Pascal and C++ in both VCL and FireMonkey apps. AppTethering was first introduced in Rad Studio XE6, and the AppTethering intercept event handlers for the encryption hooks was introduced in Rad Studio XE8. This skill sprint will use C++ examples, and 2 days ago, on Tuesday, the 19th of January, I presented the Delphi skill sprint on the same topic and used Object Pascal examples. And since the AppTethering encryption hooks work with both FireMonkey multi-device apps and VCL Windows apps, means you can use these AppTethering and AppTethering encryption hooks on Windows, Mac OS X, Android, and iOS apps. For this skill sprint, I'll quickly define what is AppTethering and what can you do with it. We'll look at these 4 new event handlers to use as AppTethering encryption hook events to allow you to encrypt the data or stream before sending the information to other AppTethered applications, and then we'll use the on after receive events to decrypt the information after it's received by the tethered apps. And we'll look at some examples on how to use these events to encrypt and decrypt the data and streams, and we'll have time at the end for any live questions and answers you might have. So what is AppTethering and why use AppTethering? Rad Studio includes a feature called AppTethering, which is designed for mobile and the Internet of Things. AppTethering enables discovery and interaction with applications running on iOS, Android, Windows, or Mac OS X, including the ability to gather data or trigger actions on those remote applications. So for example, you could scan barcodes on a smartphone and have the data sent to a Windows VCL app. And the connections can be made over Bluetooth Classic or using TCP/IP network Wi-Fi. AppTethering was first introduced in Rad Studio XE6 as a way to extend your Windows VCL and FireMonkey apps to other companion applications. And those companion applications can be Windows, Mac OS X, and or FireMonkey multi-device apps. So with AppTethering, you can properly, safely, and securely exchange streams and data messages between apps, and you can execute remote actions like pressing a button remotely or moving a trackbar remotely. With AppTethering, you can breathe new life into your existing Windows apps by extending Windows, VCL, and FireMonkey apps, connecting devices, sensors, data, and services to build connected apps to add to a distributed Internet of Things solution. So with AppTethering, you can build connected apps. You can use AppTethering components to build connected apps to add to a distributed Internet of Things solution. The AppTethering technology lets you easily distribute an existing app user experience across devices and gadgets. And this is especially powerful for extending the utility of existing VCL desktop and mobile apps to integrate with the Internet of Things. And you can, once again, either use network Wi-Fi or Bluetooth Classic with AppTethering. So we see it today. We are surrounded by all these gadgets and wearables. So there are all kinds of Internet of Things devices that we can now connect to using Rad Studio 10 Seattle. With AppTethering, you can breathe new life into your existing Windows apps by extending Windows VCL and FireMonkey apps, connecting devices, sensors, data, and services. Here we see two examples of using AppTethering. This app on the left shows sending data between app-tethered connected apps, and the app here in the middle shows sending streams, images, between connected apps using AppTethering. Now with AppTethering, we can share or send data or streams between two or more app-tethered connected applications. And for security, we need to encrypt the data and streams before sending to any connected app. And then we need to decrypt the data and streams when it's received by any of the connected apps. Rad Studio XE8 introduced these four new intercept event handlers to the tethering app profile component to intercept the data or stream, allowing you to add custom encryptions to the data or stream before sending to app-tethered connected apps, and then use the intercept event handlers to decrypt the data or stream. The four new event handlers are on before send data, and on after receive data, on before send stream, and on after receive stream. Let's now go into C++ Builder 10 Seattle and look at some example apps on how to use these intercept event handlers to encrypt and decrypt data and streams in AppTethering applications. So using AppTethering, this DesktopCast project is a sample application with a client-server architecture where a client application can connect to a server application and receive a screenshot taken by the server application once or every 5 seconds, all using AppTethering to do this. The server application is a Windows VCL application, and the client application is available both as a VCL application and as a FireMonkey application. In the server application, we have a Take Full Screenshot button that takes a screenshot and shows the screenshot. The Start Live Cast button starts taking screenshots every 5 seconds and showing them. The Stop Live Cast button stops taking screenshots. In the client application, we have a Connect button that establishes a connection to the running server application. Clicking the Connect button calls the AppTethering Tether Manager's Auto Connect method that starts the automatic connection to remote managers on each registered adapter, either using network Wi-Fi or Bluetooth Classic. When the connection search finishes, the Tether Manager's event on-end auto connect fires, and you get a list of other app-tethered app profiles that you can connect to, and we display the connected app profile that we are connected to in the caption of the label at the top of the application. On the client app, the Take Full Screenshot button executes the server action to take a screenshot remotely using AppTethering. Clicking the Start Livecast button executes the server action to start taking screenshots every 5 seconds remotely using AppTethering. And clicking the Stop Livecast button on the client executes the server action to stop taking screenshots, also all using AppTethering. When the server application takes a screenshot, the server application shows the screenshot on its T-image component and also shares the screenshot with the client application that also shows the server screenshot on its T-image component. But before the server sends the stream screenshot to the client application, we want to encrypt the stream screenshot before sending to the client, and then when the client receives it, we want to decrypt the stream so we can view it. These applications are sharing stream resources between each other, and to create a stream resource, we use the tethering app profiles property called resources to create the stream. So we created a stream called bitmap cast with a resource type of stream. The other resource type is data. So using app tethering, you can send data and or streams between other app tethered applications. But for these applications, we're only going to share stream resources. These apps also have an edit box to allow you to enter in the password text to be used by our encryption algorithm to generate the key for the encryption and decryption of the screenshot streams as they are being sent to the app tethered connected apps. The app tethering sends the stream resource from the screenshot to the connected tethered apps when there is a change in the resource stream. But before the stream is sent, the tethering app profiles intercept event handler called onBeforeSendStream fires, and here is where we can encrypt the stream, and in this case we're using an encryption called Raindoll from the Lockbox library to encrypt the stream. Raindoll is the block cipher algorithm that has been selected by the United States National Institute of Standards and Technology as the candidate for the Advanced Encryption Standard, AES, and it's included in the Lockbox library. So this is the onBeforeSendStream intercept event handler that we use for the post-processing of the stream data that occurs before the application profile sends the stream to the remote application. So here is where we encrypt the stream data, and then we put the result in a output stream. On the connected client app tethering apps, the tethering app profiles on resource update and or on resource received events fire since we received a new or updated data resource stream. But before the stream is received by the connected client tethered apps, the tethering app profiles intercept event handler on after received stream fires, and here is where we can decrypt the stream using the same Raindoll algorithm for decryption from the Lockbox library. It's important to mention that you can use any custom encryption to encrypt and decrypt data and or stream resources using app tethering using these new intercept event handlers. For this example, we use the Lockbox Raindoll encryption with streams. But once again, any custom encryption can be used with app tethering and these new intercept event handlers. Let's now run these apps and see how they work. Let me first run the AppTethering server app. And now I'll run the AppTethering Client app. The two AppTethering apps are running. On the AppTethering Client app, I will click the Connect button, and this establishes a connection to the running server application by calling the AppTethering Manager's Auto Connect method, and that starts the automatic connection to remote managers on each registered adapter. In this case, I'm using network Wi-Fi, or I could have also used Bluetooth Classic. And when the connection timeout is reached, the tethering manager's event on end auto connect fired, and that gave us a list of other app tethered app profiles that I can connect to. And here we display the connected app profile that we are connected to, which is our app tethering server app. On the app tethering server app, I'll click the Take Full Screenshot button, and this takes a screenshot, and it shows the screenshot on the app server app, but it also sends it to all the app tethered connected client apps. But we know, using app tethering now, before the stream is sent to the app tethered connected apps, the intercept event handler on before send stream fires, and that allows us to encrypt the stream before sending, and then when the client receives the stream, we use the intercept event handler on after receive stream to decrypt the stream, allowing us to view the stream on our client apps. So all of this is working great. For additional techniques for the encryption and decryption of data and streams, you can use TurboPowerLockbox. You install Lockbox using the Get It package manager from the IDE. TurboPowerLockbox is a free and open source Delphi and C++ builder cryptographic library providing efficient private key encryption, public key encryption, and hashing functions. It provides support for AES, strong encryption, DES, weak encryption, 3DES, blowfish, twofish, SHA, MD5, a variety of chaining modes, RSA, digital signature, and verification forms of encryption. This ends what I had time to cover on this skill sprint on encrypting AppTethering send, receive data, and streams. For additional resources on encrypting AppTethering send and receive data and streams, look at this DocWiki link on using AppTethering. For AppTethering using encryption hooks, look at this blog post on community.embarcadero.com. And also look at this Lockbox homepage for additional examples on how to use Lockbox encryptions with C++ Builder apps. And also go to this blog notes link, embt.co/sprint-tether-crypto, to get the replay of the session and additional information, including links for other sample projects used in this skill sprint. For additional AppTethering examples, look at the samples provided in C++ Builder 10 Seattle. The database shopping list app shows AppTethering sharing data resources between other paired profiles. The DesktopCast app shows AppTethering sending streams of screenshots and actions to other paired profiles, just like we saw in this skill sprint. The Media Player app shows AppTethering executing remote actions between other paired profiles. And the Desktop Beacon Cast app shows how to use the T-Beacon component in a client application to scan for beacon devices, and remote actions are executed to take and get a screenshot from the server by sending streams between other paired profiles, similar to the app we just saw in this skill sprint. Next time, if you use Delphi and Object Pascal 2 days ago on Tuesday the 19th of January, I did the same AppTethering skill sprint but used Delphi and Object Pascal examples. And you can always go to the blog notes link to get the sample apps that were used in these skill sprints. And for next week's developer skill sprint on Tuesday the 26th of January, we will cover practical data compression and decompression using Object Pascal. And on Thursday the 28th of January using C++. And you can always see the full skill sprint schedule and replays at embt.co/sprints15. Let me quickly turn this session over to Jim McKeith from Developer Relations to let you know what are the current RAD Studio, Delphi, and C++ Builder special offers for this first quarter of 2016, and then I'll come back for any live questions that you might have.
Give me a brief moment to tell you about this limited time special offer. All 10 Seattle registered users get the bonus pack, which includes the new Object Pascal Handbook by Marco Cantu. This essential language reference is a modern language guide that includes new features of the language and the core runtime library, a must-have for any Delphi developer. Also get the Binder Converter Basic. It handles the heavy lifting when converting existing VCL applications into FireMonkey applications, so you can start taking advantage of multi-device development right away. And the Premium Style Pack includes premium styles for VCL and FireMonkey to make your application look great on every platform. For more information on these special offers, or to find out what the current offers are, please visit www.embarcadero.com/radoffer.
Thank you, Jim, for letting us know all those great special limited time offers. This ends this C++ developer skill sprint on encrypting app tethering for send and receive data and streams. You saw how you can use the new app tethering encryption hooks in C++ Builder to encrypt the data or stream before sending the data or stream to other app tethered connected devices, and how to use the encryption hooks to decrypt the data or stream after receiving the data. Thank you all for attending. Now, let's open up this session for any live questions and answers you might have.
Okay. Uh-oh. And with me is Jim and Al. This is David I. Hey, guys.
Al is on. Can you hear me, Jim and David?
Sure can.
Excellent. All right, thank you all for attending. A few questions we'll go through right now. So Ahmed asks, with this app, does app tethering require open SSL, and/or certificates? So the answer is really no. No open SSL or certificates are required. So what we did with app tethering, and this was a feature that's been requested for a while now. So before you send any data and/or streams to other app tethered connected apps, folks wanted to be able to encrypt the data and/or the streams. So we added those 4 intercept event handlers, allowing you to intercept the data and/or the streams before sending, and in those interception hooks, you can do whatever you want to the data. And one thing to do is to encrypt the data. So you could add your own custom encryptions or use any of the encryptions that's available inside of Lockbox that you can get, that's included inside of RAD Studio, and you can install it from the Get It package manager. So hopefully that answers the question. Another question is, are those Lockbox components, will they always be available in the Get It package manager forever? So my understanding is that we do have active plans to keep Lockbox updated and available in the Get It package manager. So Lockbox is a free and open source software, but like I said, for the foreseeable future, we do plan to keep most of the TurboPower products part of the Get It library. For example, Orpheus is in there, and many of the other TurboPower, TurboPack products are available inside the Get It package manager. Now, when you go to the Get It package manager and you look up Lockbox, you'll see 3 different versions to install. One is version 3.5, and there's 2 other 2.0 versions. For C++, we found that the VCL and FireMonkey 2.0 version was the most complete compatible version that worked with the current C++ Builder 10 Seattle. Now, we found that the Lockbox 3.5 was not completely compatible with C++ Builder. So if you want to do what I just did here, for C++ Builder 10 Seattle, we use Lockbox version 2.0, FireMonkey, and VCL, and we did not have any issues with any C++ Builder application. Another question is, can this be used with DataSnap REST servers? So is the question using Lockbox encryptions? Because with DataSnap servers, we have filters that allows you to include your own type of custom encryptions or compression. So that's what we do with DataSnap. Use the filters that are provided with DataSnap to allow you to add your own custom encryptions or compression algorithms. So hopefully that was the intent of that question, and hopefully that was the answer. So if you saw in the code, it was quite easy to add lockbox encryption to those custom event handlers. So for the example I used, we picked Lockbox's strong encryption AES, which is their Randall implementation. And all you had to do is drop that Lockbox Randall component onto the form, and then call its generate key method and pass it in a password text that it's used to generate the key. And then that component has an encrypt stream method and a decrypt stream method. So all you have to do is call its encrypt stream method, pass in the stream to encrypt it with strong encryption AES, and then to decrypt it, just call a decrypt stream method. Once again, pass in the stream to decrypt it. So it's as easy as that to add strong encryption AES using the lockbox components.
Okay, great. Thanks, Al. If there's any other questions for Al, go ahead and put them in the question panel and get them answered for you.
Okay. And those list of sample apps you see on the screen now, each one of them, some are sharing data, some are sharing both data and streams. So using the same techniques we saw in this example, you could intercept the data and or the streams going between the apps and add custom encryptions to encrypt the data and or decrypt the data as you're sending and receiving the streams. So it's as easy as that.
If you're sending data, do you need to handle the data events and encrypt it there, and then the streams are only encrypted with streams, or is everything get encrypted?
That's correct. No, so if you're sending data, you also have to implement the on before send data and on after receive data events.
So if you're just sending like a string or something like that. Okay.
Yeah. So streams go with the stream events and data go with the data events. So you'd have to implement both of them. That's a question. So let's say you wanted to send a stream and then a data part that describes what the stream is, and you want to encrypt both the data part and the stream part. You would use the on before send data to encrypt the data, and then on before send stream to encrypt the stream, and then do the inverse on the client apps receiving them, call the on after receive data and on after receive stream to do the decryption.
It seems like if you wanted to use tethering, Al, in other types of applications to just tether to like console apps together or to, I don't know, server-side apps together, there's no VCL I mean, there's actions, but it seems like if you have a tether manager and tether profile in two different apps, regardless of whether they have UIs or not, they should be
That's correct.
Then between each other.
Correct. See, that's correct. So these can be two Windows VCL apps or two FireMonkey apps, or they can be console apps, or they can be console server apps. They don't have to have the user interface.
Yeah, they just need Action Manager if you're going to send actions, action lists, and then they just need the Tether Manager and Tether Profile, and whatever is reachable, right? I mean, because of IP addresses or UDP on a subnet, all the usual rules have to apply. You couldn't have a data snap server off in a cloud somewhere on a different subnet. If you wanted to do discovery, you'd have to know the IP address of those pieces and parts, but should be all correct.
And then in addition to sending data and streams, AppTethering also allows you to execute remote actions like pushing a button. So we saw in these sample apps, the client app was able to push the take a screenshot button. That would push the button on the server app to take the screenshot. And that's done through actions and action lists that AppTethering allows it to do also.
Like it's the question about which header files get added to the include when you add objects to a form, but you can just put those header files, you can just include those header files yourself, or I think tethering is in the system unit, and if it's in the system unit, let me double check. Things that are in the system unit are not specific to any framework, so make sure that you just include those header files that you need for the non-visual components you're going to use. If anything, you could always put a data module in your app. A data module is like a form, but it has no user interface, but it can contain non-visual controls, and a data module doesn't have to have database components in it. It can contain anything. So let's see, REST client components. Again, the REST client components are non-visual. Like if you have a console app, create a data module, or you can create the components, instances of the objects on the fly, since you're not dropping them into something. You can create a console app that's a quote-unquote VCL or FireMonkey console app, even though you're not going to display anything. I think that's one of the options. But
so this is something we can try to do: create some console apps that are tethered. So I can post that on the blog notes link to show you how we did it, if it's possible.
Yep. Again, the rule of thumb is if it's in the system unit and not in the Windows API, that's specific to an operating system. But if it's in the system unit, it should be agnostic. But I'll have to try it myself. I'll have to drag create a console app and just instantiate the object. For example, the tether manager. You can call the constructor, and you just encode, and you just need to make sure that you include the header file. So, all right, there's a challenge there, is to see about using app tethering in a console app, two console apps talking to each other. That'd be a great little example to add.
Yeah, I've used that technique with data modules when I have complex console applications. Actually, frequently I'll create a project that has a data module and then a GUI version of the application and a console version of the application. Usually the console version will be like my unit test and stuff like that. And it uses that same data module, and then I can from the console app to do quick tests. I don't have to go through and tap buttons in the UI. And so it just uses that data module, and that has all my non-visual controls on it, whether they be REST controls or data controls, data access controls, or whatever. I haven't tried it with tethering, but I suspect it should totally work with tethering as well.
Challenge accepted. We'll probably all write everyone's, because there was two different ones. A console app maybe with tethering, and then there was can use the REST client components, which again are non-visual in other things that aren't. I've done it server side. I've dropped REST components in a DataSnap server, but a DataSnap server can have a remote data module, or depending on what you choose for your DataSnap server, it doesn't have to have a user interface. So it's just a matter of including the right header files and calling the constructors, or if you've got a data module or remote data module or whatever, dropping the non-visual component in that container, which will then do the creation for you. So when the data module is created. So good stuff to try. I'll turn it back over to you, Jim. Sorry.
No, that's good. I think we're done. So thank you so much, Al. Thanks, everyone, for joining us. We'll see you all next week. We'll talk about compression, decompression, which you can actually use the compression stuff with app tethering just in the same hooks there if you wanted to, I guess. So, mind. See you all next week.
Correct. And some of those lockbox methods do compress first. They do compress and they do encryption at the same time, I believe. All right. Thanks again, everyone, for attending. Have a great day, and hopefully you don't get as much snow as I'm going to get here in New York City.